Okay, we're on section 2.2, subsets. All right, and I mentioned this a little bit last time, but now we'll really get into it today. All right, so for the definition of a subset, A is a subset of B if and only if X is an element of A implies that X is an element of B for all X. So in other words, every element, so A is a subset of B means that every element of A is also a subset of, or is also an element of B. And then it's also showing you the notation for is a subset of, and if you put a slash through it, that is not a subset of. And then a proper subset is just a subset that is smaller than the bigger set. So let's look at some examples. So it says A is a set of all natural numbers greater than 6. So if we wanted to write that using the roster method and just kind of list them out, that would start at 7 and then it would be 8, 9, etc. from there. Everything's bigger than 6. And then B has 1, 2, and 3, and C has 8 and 9. Okay, so we want to determine if B is a subset of A. So is B a subset of A? No, it's not. B has 1, 2, and 3, and then A has everything, above 6. So B is not a subset of A. So we could do, so the symbol for is not a subset of. It's like this. All right. Number 2, is A subset of B? That's also a no. Number 3, is C a subset of A? Yes. So C has 8 and 9, and A has 7, 8, 9, 10, etc. So C is a subset of A. All right, and it's also true that C is a proper subset of A because C is a smaller set than A. So almost all subsets are also proper subsets. The only subset that's not a proper subset is the actual same set itself. So it's kind of like the same idea as talking about, if I said, I could say that 5 is less than 6, that would be a true statement. I could also say 5 is less than or equal to 6, that would be true. But I could say 6 is less than 6, that wouldn't be true. I could say 6 is less than or equal to 6, but if I said 6 is less than 6, that would be false, all right? But those other ones are true. So it's the same kind of thing. So every subset is a proper subset unless it's equal. All right, number 4 says the empty set is a subset, or we're figuring out, is it a subset? So yes, the empty set is always a subset of every other set. And it's also, it's not equal, so it's also a proper subset. Kind of like saying that, you know, it's smaller than every other set. All right, number 5, we're comparing a set containing the number 1. So is that a subset of B? Yes. It's also a proper subset because it's not equal to B. And is C a subset of C? Yes, but it's not a proper subset because it's equal. Okay, true or false? Number 7 says a set containing the number 8 is a proper subset of C. Is that true or false? That is true. It's a subset and it's smaller, which means it's also a proper subset. All right, number 8 says 9 is a proper subset of C. So that is actually false. So this is like I talked about this a little bit last time, the difference between, you know, a set that contains a number versus the actual number itself. So 9 is not a set, so therefore it can't be a subset of anything. 9 is just a number. So in order to make that a true statement, you would have to put the curly braces on the 9. So if you did that, if you said the set containing the number 9 is a proper subset of C, then it would be true. But just the number 9 is not even a set, so it can't be a subset. And then number 9 is saying the empty set is a proper subset of A, and that's true. Because pretty much the empty set is a subset of everything. And then number 10 says B is a subset of the empty set. So that would be false. The empty set doesn't really have any subsets other than itself. And then number 11 says the empty set is not a subset of C. That would be false because it is a subset of C. Because it's always a subset of every other set. Okay, number 12 says list all the subsets of B. So B was 1, 2, and 3. So I'll start with the smallest subset, which is always the empty set. And then you have a set containing 1, a set containing 2, a set containing 3, a set containing 1 and 2, a set containing 2 and 3, a set containing 1 and 3, and then the whole thing. So you could just write B, or you could write out 1, 2, and 3. Those are all the subsets of B. There's a total of 8 of them. So you always have to put the curly braces around it to show that it's a set.
All right. So to find the number of subsets, you do 2 to the power of how many elements are in the set. So for number 13, that set has 6 elements. So if we want to know how many subsets it has, we would do 2 to the power of 6. Which equals 64. So that set would have 64 total subsets. And then how many proper subsets does it have? So all subsets are proper except for one, which is the whole set. So if it has 64 subsets, that means it has 63 proper subsets. Number 14, set A is the set of all WC students, set B is the set of all female WC students, and set C is the set of all married female WC students. So true or false, C is a subset of A. So that would be true, because every element of set C is also an element of set A. All right, and then this last statement, is this true or false? If X is an element of A, then X is an element of C. So that would be false, because there are elements of A that are not elements of C. For example, the male WC students would be an element of A but not C, so that's false. If you reverse the A and the C, then it would be true. A week from today. Mm-hmm. Yeah, and I've got the test review that I'm gonna hand out today.
Are you gonna put like the Model Apps plus grades in Canvas to like a test?
Yes. Especially if you send me emails and ask me to do it. All right. So on 2.3, we're talking about operations on sets such as union and intersections. All right. So the union of two sets, so A union B, contains all the elements of A, plus it also contains all elements of B. So union is often associated with the word or. So if something is in A or if it's in B, then it is in A union B. All right. So, for example, let me see here. So using that same example from 2.1, remember we had these two sets A and B. So A has 1, 3, and 10. B has NX 0, 10, and 23. So the union of those two sets contains all of those elements. And then the intersection of two sets so the symbol for union basically looks like a capital U, and then the symbol for intersection is basically the same thing, but it's flipped over. So it kind of looks like an N, which to me helps you remember it, N for intersection. So the intersection is all of the, basically the overlap, whatever's in both. All right, so that's often associated with the word and. So like if something is in A and it's also in B, then it's in the intersection. So using that same example, then the intersection just only contains the number 10 because that's the only thing they had in common. And then the complement of a set is everything that's not in the set. So it's denoted as A with like a little apostrophe or something, or accent mark type thing after it. All right, and I will often read that as A prime, or maybe not A. So to me, this is where you can start to see parallels between chapter 2 and chapter 3, because in chapter 3, we had and, we had or, we had not, and in chapter 2, we have intersection, we have union, we have prime or complement. So those like go together. All right, and so here's a Venn diagram. So it's just a visual of how two sets are related to each other. So this circle represents set A, and this circle represents set B. So the part where they overlap, the purple part in the middle, that's the intersection of A and B. And then the whole shaded area is the union. And the box that they're in is the universal set. So we usually call that U. Universal set. All right. So we want to find the union and the intersection. I always like to do the intersection first because it's just smaller and easier. So the elements that these two sets have in common are 1 and 5. So when we fill in the Venn diagram, those would be in there. And then the other elements of A are -7 and -3. And the other elements of B are 9 and 13. So that's how the Venn diagram would be filled out. And then for the union, so the order doesn't technically matter, but I usually try to put them in order from smallest to largest if I have a list of numbers, because that just seems to be, just makes sense to me, but you don't necessarily have to. So the union has -7, -3, 1, 5, 9, and 13. And again, you only list each element one time when you're listing them like that. So on number 2, what elements do those two sets have in common? Nothing. So the intersection of A and B equals the empty set. So when you fill out your Venn diagram, it's just going to look like this. A, E, I, O, U, C, D, F, G. So if I'm doing letters, a lot of times I like to put them in alphabetical order, but in this case, it's not even worth it really. I'm just gonna list all the ones from A and then list all the ones from B. All right, and you always have to put the curly braces around your list to show that it's a set. All right, number 3. So the universal set is defined to be the set of all natural numbers. And then A is the set of all even numbers. And B is numbers 1 through 12. So for A, we could also write it out using the roster method, sort of. We could just say 2, 4, 6, dot. You know, if you want to write it out that way, we can do that. I know those curly braces are really hard. I still struggle with them, especially when I'm writing them on the screen. All right, so like I said, I always like to try to start with intersection because that just seems a lot easier. It's smaller. So what elements would be in the intersection of A and B? So 2, 4, 6, 8, 10, 12. All right, and then the union is going to be a little bit awkward to write out. And I am going to try to, I think it's important in this case to try to put them in order, just so it'll make some kind of sense. So basically, we're going to have everything from 1 to 12. 1, 2, 3, dot, dot, dot. 10, 11, 12. Okay, and then after that, we would just have, after that, we would have all the even numbers that are coming after that. So we would have 14, 16, 18, dot, 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 dot. All right. So the complement of A. So that's going to be, so before you can ever define the complement of the set, you have to know what the universal set is. So we know the universal set is natural numbers. So the complement of A is everything from the universal set that's not an A. So in this case, that would basically be odd numbers. So we could write it out using that set builder notation, just like it was written out here, and just change the word even to odd. That's one way you could do it. I'm just gonna go like this: 1, 3, 5, dot, 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 dot. Okay. And then the complement of A union B. So if this was on a test or something, if we hadn't already defined the union of A and B, it might be helpful to do that before trying to answer the complement of the union. But so we've already done that. So what elements, so if we can just look at the union that we already defined, and then what elements are not in there? So what would be the first number that's not in the union? So the union has everything from 1 to 12. So 13 is not in there. And then what else is not in there? 15, 17, 19, et cetera, like that. All right, and then B prime, or in other words, the complement of B. So what elements are in the complement of B? So what elements are not in B?
Oh, wait, just kidding. I was looking at an answer, not B. 13.
Mm-hmm. 13, and then 14, and then 15, and then everything else up from there. All right, and then next we have A complement intersected with B. Okay, so again, if we hadn't already defined A complement, it would probably be helpful to do so first. So basically, I'm just gonna look at, now that I've already done that, I can just look at A complement and look at B, and then write down a list of everything that those two sets have in common, which would be what? 1, 3, 5, 7, 9, 11. All right, then we're looking at A intersected with the empty set. So what elements does A have in common with the empty set? Well, what elements are in the empty set? Nothing. So what does A have in common with nothing? Nothing. So that's the empty set. So the empty set intersected with anything is always the empty set. It's kind of like multiplying by 0. All right. What about B union the empty set. So that's everything from B plus everything from the empty set.
Just the B then.
So it's just B. It's like adding 0. All right. All right, so on number 4, we start with a Venn diagram and go from there. So I still like starting with the intersection first because it seems to be the easiest thing. So in the only thing in the intersection is a heart. All right, and so this is kind of just, part of this is just proving the point that the elements of a set can be anything. It's not just letters and numbers. It can just literally be anything. All right, let's see, the union then, let's see. So we have so we have in the union, then we have a star, a fish, a heart, a smiley face, and 73. So that's the union. All right, and then A prime, so A complement, everything that's not in A would be heart, no wait, heart is in A, just kidding. Smiley face, 73, and green. Okay, and then B prime, everything that's not in B is star, fish, green. And then A prime intersected with B. All right, so another way you could think of that is everything that is in B that is also not in A. So that would just be, so everything that's in B that's not in A is this section here. So just those 2 items. Smiley face, 73. And then the complement of the union. So the union is everything in the circles. So everything not in the circles is green. Okay, and then we have B union with the complement of A union B. So again, it's really helpful the fact that we already have done the complement of A union B. So everything in B plus everything here. So everything in B is heart, smiley face, 73. And then add in everything from the complement of A union B, which is just green. All right, so something that has a lot of parts like that, it definitely helps to have like each part done individually. That would have been pretty hard to figure out without having already done the complement of A union B right there. All right, so the number of things in the union of A and B is equal to the number of things in A plus the number of things in B minus the number of things in the intersection, okay? So you always have, so when you add everything from A plus everything from B, whatever's in the intersection has been counted twice. So that's why you have to subtract whatever's in the intersection. So it's only counted once. So if A has 10 things and B has 6 things and A and B have 2 things, how many things are in A or B? So it's just wanting you to do 10 plus 6 minus 2. So that's 14. So for example, in that problem that we were just working on, if you look at it, A has 3 things and B has 3 things. So 3 plus 3 would be 6. But then you have to subtract 1 to get 5. And if you look at it, if you just count all of the elements that are in the union, you count 1, 2, 3, 4, 5. All right. Here we have one with 3 circles. Yay. Okay. Let's see here. So our universal set is the natural numbers up to 10. So you might like to write these out using a roster method. Don't have a ton of room there, so I'm just gonna do it like this. And then A, so all of A, B, and C are all gonna be like subsets of that universal set. So A is all the evens, B is all the odds, and then C is everything from 2 to 8, but not including 2. So A is 2, 4, 6, 8, 10. And B is 1, 3, 5, 7, 9. And C, like I said, doesn't include 2, so it starts at 3, 4, 5, 6, 7, and it does include 8. So again, let's start with the intersection and fill out our Venn diagram. So what elements are in the intersection of all 3? Nothing, because A and B don't have anything in common. So you would put nothing there and you would put nothing there in your Venn diagram. Let's see, what about the intersection of A and C? What would we put in there? 4, 6, 8. All right, and then the intersection of B and C, so what we want to put in here would be 3, 5, 7. Okay, and then let's see. What else do we need to put in A that we haven't already listed? 2 and 10. And from B, 1 and 9. And that's it. So that's all the elements. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got them all in there. So that's our diagram. Okay. So A intersected with the universal set. That's just A. All right, A intersected with C prime. So things that are in A that are not in C. So it might be helpful if you wrote down C prime first. But you could do it without doing that. So everything that's in A that's not in C. So that would be this area here. Everything that's in A that is not in C. So that's just 2 and 10. Okay. B intersect C prime. So things that are not in the intersection of B and C. So you might want to do this by writing out the list of everything that is in the intersection of B and C and then do the complement of it. Or we could just probably use our Venn diagram. So the intersection of B and C is this, whoops. The intersection of B and C is this area, which means basically everything out, if we're doing the complement, we want everything outside of that area. So everything outside of that. So everything outside of that would be like, you know, all this, anything in here. So basically that's going to be 1, 2, 4, 6, 8, 9, 10. One, 2, 4, 6, 8, 9, 10. All right, number 8, we have a Venn diagram. Okay. So for the purposes of this problem, we're going to assume that anyone who is not female is male. So in that case, the people here that are males are anyone that's not female. So anyone outside of that female circle. So Ronnie, Jim, Joe, Brad, and Tim. And then which of these people are males who like math? Okay, so that would be males that like math, so they have to be inside the like math circle, but outside the female circle. So that would be Ronnie, Jim, and Joe. All right, and then which of these people like math? So all the people in the like math circle. So that would include Ronnie, Jim, Joe, Leslie, Sydney. All right. So that's the end of chapter 2. Here is the practice test review. So you can find this exact document on Canvas under modules, as well as the answer key for it. If you want extra practice, I believe you can find some worksheets on there as well for chapters 2 and 3. If you can't, just let me know. I believe they're on there. And they also have solutions as well. So those would be some good extra practice for you to work on over the next 5 to 7 days. Our test will be a week from today. All right. Any questions about anything? All right. Y'all are free to go.